Hello, and welcome to ResearchPod. Thank you for joining us today. In this episode, we'll be looking at the work of Johannes and Marlene Hager, who carry out their important research within the clinical division of gynecological endocrinology and reproductive medicine in the Department of Obstetrics and Gynecology at the Medical University of Vienna in Austria. Is currently investigating the causes of secondary amenorrhea, also known as paused periods or missed periods, which are not due to pregnancy. In a 2022 study, and his research team evaluated women with functional hypothalamic amenorrhea, or FHA, one of the most common types of secondary amenorrhea. In simple terms, women with this condition do not ovulate, with the aim of providing new insights into the hormonal profile of FHA and, in turn, helping women with the condition. Ott's team wanted to find out whether there was a difference between women with and without Polycystic Ovarian Morphology, or PCOM. PCOM was defined as a follicle number per ovary of at least 12 and/or an ovarian volume of more than 10 cc's in at least one ovary. Specifically, Ott and his team wanted to understand the response of these groups to a gonadotropin-releasing hormone stimulation test, considered a useful diagnostic tool for FHA, and to Lutraleaf or Lutrapulse system, pulsatile gonadotropin-releasing hormone treatment, which is capable of restoring ovulatory function in the majority of affected women. FHA is a lack of ovulation over a long period with no known natural cause, such as pregnancy. This is a direct result of a functional reduction in or into the secretion of pulsatile gonadotropin-releasing hormone, resulting in low ovarian function. However, it is believed that FHA can be reversed by stopping the behaviors that caused it. Ott and colleagues based their 2022 study on the recent work of Marlene and colleagues. Marlene's team found significantly lower serum levels of anti-Müllerian hormone in women with FHA who did not have PCOM. It is worth noting that a woman's anti-Müllerian hormone levels correspond to the number of eggs she has in her ovaries. More specifically, her body needs it to regulate the selection of follicles for ovulation as well as the growth of follicles. Based on their clinical findings, Marlene and colleagues concluded that women with FHA should not be diagnosed with low ovarian reserve by a reduced anti-Müllerian hormone level alone. Importantly, this study also highlighted the group of women who have FHA and PCOM. Ultrasounds show this group have a high number of small, hollow follicles. They also have increased anti-Müllerian hormone levels compared to the control group and to women with FHA but not PCOM. The results from Ott's study agreed with those of Marlene and colleagues in that women with FHA and PCOM have low serum levels of anti-Müllerian hormone. Marlene hypothesized that women with FHA have low anti-Müllerian hormone levels due to a relative follicle-stimulating hormone deficiency. This causes a reduction in the pool of growing follicles and a resulting reduction in anti-Müllerian hormone production in the ovaries. Ott and colleagues confirmed and contributed further evidence to this hypothesis. For instance, they demonstrated a positive significant relationship between serum anti-Müllerian hormone levels and basal follicle-stimulating hormone levels. What's more, Ott was able to show that women with FHA, but not PCOM, experienced a significant increase in serum anti-Müllerian hormone after 3 months of Lutraleaf treatment. Additionally, these women experienced a non-significant increase in basal serum follicle-stimulating hormone. This finding supports the hypothesis that low AMH is not due to diminished ovarian reserve, but the lack of GnRH and FSH signaling typical for FHA. However, Ott disagreed with Marlene on one point relating to the association between serum anti-Müllerian hormone and luteinizing hormone levels. Unlike Marlene, Ott found a significant positive association in women with FHA but not PCOM and in the control group. However, the different results can be explained by differences in the study populations. Importantly, both studies agreed that anti-Müllerian hormone has a stimulating effect on gonadotropin-releasing hormone neurons and the responsiveness of the pituitary gland to that hormone. Ott and colleagues were not able to explain why sonography revealed that 42% of women with FHA had PCOM, but this prevalence is higher than in women of a similar age in the general population. In agreement with Marlene, Ott found a positive association between serum anti-Müllerian hormone levels and body mass index unique to this subgroup of women. Marlene's team thought that this could be because these women had initially had the metabolic burden typically seen in polycystic ovarian syndrome, or PCOS, before losing weight. This group also had lower sex hormone-binding globulin levels, which supports this assumption. But why is there a higher rate of PCOM in women with FHA compared with the general female population of a similar age? Possibly it is because women with PCOM or PCOS are more prone to inhibition of the gonadotropin-releasing hormone neurons resulting from weight loss and other causes for FHA than women without PCOM. Interestingly, Ott's team also found similar levels of basal luteinizing hormone levels and basal follicle stimulating hormone levels in women with FHA with and without PCOM. However, this still leaves the issue of dysregulation in the ovaries of women with PCOM, regardless of having low gonadotropin levels. The researchers suggest that this phenomenon could be explained by epigenetic reprogramming in the womb. Epigenetics refers to changes in a cell or organism due to an alteration in gene expression or other effects that do not involve changing the DNA sequence itself, especially those that are inherited. This might explain why a reduction in gonadotropin, typically seen in FHA, would not affect the excessive anti-Müllerian hormone in women with PCOM or PCOS. Essentially, researchers have produced similar findings about the association between anti-Müllerian hormone levels and luteinizing hormone levels in women with FHA in addition to PCOM and women with PCOS. This discovery presents a question. Is PCOM seen in women with FHA just a normal variant, like it is in the general population? Or is it a hidden type of PCOS in which characteristic excess of androgens is overridden by chronically low luteinizing hormone levels? Ott and colleagues acknowledge that their study is too small to draw definitive conclusions. However, they note that both hypotheses could be true and are not necessarily mutually exclusive. This is because women with FHA reacted similarly to the Lutraleaf treatment whether or not they also had PCOM, supporting the first hypothesis. However, in support of the second hypothesis, some researchers have reported an unmasking of PCOS following Lutraleaf in a subgroup of women with FHA. To conclude, the data from Ott and colleagues' study showed that women with FHA, in addition to PCOM, have some similar characteristics to women with PCOS, supporting another previous study by Mayerfer and colleagues. In cases where doctors mistake FHA for PCOS, women may not receive the treatment they need, resulting in the long-term consequences of estrogen deficiency, as described by Beidel and colleagues. Therefore, this recent study highlights the importance of differential diagnosis between functional hypothalamic amenorrhea and polycystic ovarian syndrome in women with secondary amenorrhea. That's all for this episode. Thanks for listening, and don't forget to check out the links to the original research papers linked in the notes for this episode. And stay subscribed to ResearchPod for all the latest research. See you again soon.